I welcome you all to my first lecture of the subject soil mechanics. So this is framed under Banna Raymond Institute of Technology and Autonomous College for third year students. So let me write the subject code 15 CU CE 503. So it is for third years as followed in Banna Raymond Institute of Technology curriculum. So soil mechanics. So that the subject deals with very important role in substructure. So as we all know about superstructure and substructure, substructure is nothing but a foundation and other structure which is under ground level. Superstructure is nothing but, as we are seeing, above the ground level. Superstructure are nothing but it is a load transforming structures. So we have in a building, for example, in a building we have slabs, beams and columns. As a sequence, all the loads are transformed to slabs. So then slab will be transferred their load to a horizontal member called beams. So these beams are connected at the ends with the help of a column. So the column is a vertical member which transforms all the loads of slab, both self-weight of slab and superimposed loads and beam loads, to the foundation structures through vertical member column. So the foundation is playing a major role to transform all the superstructure loads given to it, which is buried under the earth. That is the problem. It is an invisible, so we may not see that substructure by seeing at the surface. So which is playing major role to transform all the superstructure loads. So I am coming to say that superstructure, comparing with substructure and superstructure, substructure is playing major role than the superstructure, which is buried under the earth and transforming all the loads to the soil uniformly. So now we are coming to the point, under the substructure, soil is giving a wonderful platform to transform all the loads. Now in this subject we are going to deal with as one of the application of foundation. I am telling this. So soil mechanics has different applications. So as one of the application is foundation. So foundation will transform all the loads to the soil. So now we are going to talk about soil in terms of in the subject as in soil mechanics. So we have to understand the soil first. Then we have to analyze the characteristics, properties, and all. We have, then only we can we will come to know how to approach the soil to meet our applications in day-to-day life. So now coming to the point, soil mechanics. Soil mechanics, I can divide this into soil plus mechanics. So soil, as we all know, it is an disintegrated particles of rocks produced. Mechanics is nothing but it deals with forces. So I am clubbing this to soil plus mechanics. So we can apply this mechanics to our engineering design. After only you get to know about what is soil and how it will behave when you apply load and what is in behavior, then only it will complete soil plus mechanics. So it is simply nothing but, so mechanics part is nothing but an analytical part, arithmetic parts. It deals with problems and all, design everything. So it starts once you will collected the data about the soil, which means the index properties or engineering properties, whatever may be. So it is an application of law of mechanics to the soil. That is nothing but soil mechanics. So father of soil mechanics, Dr. Carl von Terzaghi, who is a great personality who developed a lot of concepts related to soil to meet our engineering designs. So he has a very much related concept to the soil. We will be discussing in later on unit 2, 3 and 4. Now before entering into the unit 1, so we have to look into the soil first. What is soil and how it got produced? So we have to learn the soil first. So let us start with the topic nature of soil. So nature of soils. So we have two different categories of soils. So we have say for example we have different types of soil: clay, silt, sand, gravel, pebble, boulders. So we have different variety according to the particle sizes. But we can put into all these types of soil into under two broad classification. It is nothing but cohesionless soil and cohesive soil. So I am coming to tell us, so all these type of soils can be categorized under two different types of soil. One is cohesionless soil, another thing is cohesive soil. So what is soil, sir? What is soil first? So soil is nothing but it is an disintegration of rocks. So rocks are nothing but parent material. So rocks are nothing but parent material. When it is subjected to weathering processes, then it will be disintegrated into rocks, into soil. So before going to the this broad classification, let us look at into the prerequisite engineering geology. So it is a prior course to the soil mechanics. So the flow will be engineering geology, soil mechanics, foundation engineering, then ground improvement techniques, geo-environmental engineering. Like that we have some sort of 4 or 5 subjects dealing with soil. So engineering geology is a very prerequisite subject. So with help of this engineering geology subject, I can explain this cohesionless soil and cohesive soil respectively. So engineering geology, what we have to learn in engineering geology? It is nothing but, for this, according to this subject, petrology and mineralogy. So we have to learn about this. So petrology is a study of rocks, and mineralogy is nothing but a study of minerals. Study of rocks is petrology and study of minerals is mineralogy. It is nothing but, it is not a study of petroleum, it is a study of rocks. Since soil are the production of rocks, first we will deal with petrology. Rocks. What are the types of rocks, sir? Types of rocks, which means in the very earlier period, so we can say earth has an age of 4.2 billion years, which is 10 to the power 12 years. So earth has, by the assumption, earth has produced as an molten magma, then it is subjected to cooling processes and it got some solid shape as a sphere, then it formed rocks. It has started forming rocks. So types of rocks: igneous rocks. Igneous rocks are nothing but which are first forming rock. We can further classify it into intrusive rocks, extrusive rocks, and hypobasal rocks. So what is intrusive rocks, extrusive rocks and hypobasal rocks? Intrusive rocks are the rocks which are produced at deeper level. So we have a difference between magma and lava. What is magma? It is in a molten state. If that molten liquid semi-solid doesn't reach the earth's surface, it is known as magma. Once it reaches the surface, it is known as lava. So in this intrusive rocks, at a molten magma at a deeper level, say at more than 10-meter level, it is subjected to cooling processes. When it is subjected to cooling processes, so the rocks produced are known as intrusive rocks. It is a slow cooling processes because it is under 10-meter deeper level. At the surface, we expect slightly lesser temperature. Slightly lesser temperature, but at deeper level, temperature will be more. That represents slow cooling. When temperature is high, it is subjected to slow cooling. Temperature is very less, it is like a rapid or quick cooling, we can say. So here it is in quick cooling. It is when this magma reaches to surface, it is turned into lava. So this lava is subjected to cooling processes. So we know at the surface there will be a lesser temperature comparing to a deeper level. So it is an, we can say it is a rapid or cooling, a quick cooling process. So it produces rocks. Those rocks are nothing but extrusive rocks. Hypobasal rocks are intermediate to this deeper level and surface, say at shallow depth. We have a moderate cooling. So what this cooling process makes, will this cooling process make difference as it is? How? In the sense, slow cooling and rapid cooling. Slow cooling, say for example, we have an glasses, we are producing glasses with ingredient of silica and all. So when it is rapidly cooling, the produced glass will be easily broken. But if a glass is during this cooling process, if it is cooled very slowly, it will be very strong rock, strong glass. If it is cooling very quickly, it will be a lesser in strength, which means we can see some of road accidents. We are seeing some road accidents at the time of impact or any sudden collision. So this glass all will be breaking into pieces. So that will be controlled by this cooling process. Those kind of property of glasses can be adjusted with this cooling temperature adjustments. So that is the concept. So I'm coming to say slow cooling process will produce harder rocks and quick cooling process will produce lesser strengthened rocks. So these are the igneous rocks. Sir, what are the examples? We can give examples as an granite and basalt. So next form of rocks are sedimentary rocks. What are sedimentary rocks? It is nothing but some sort of soil which are produced by the disintegration of rocks. So soil got already produced and we have some broken pieces of rocks that are nothing but stones. So this soil and stone got compacted and subjected to some two cementing processes, binding processes. It will produce sedimentary rocks, which means say soils and rock pieces is subjected to compaction and cementation will produce sedimentary rocks. So this process is known as nothing but lithification. So we can give example as a limestone, sandstone, concur and all. So limestone is nothing but CaCO3. So sandstone, once the sand has subjected to compaction, which means compressed, and cementation represents binding process. So these two processes, as combinedly known as lithification, can transform sand into a stone, sandstone. So that is an example for sedimentary rock. Metamorphic rock. Metamorphic rocks are the rocks. So one type of rock is changing into another type of rock. When this change occurs, so that change is nothing but metamorphism. So this morphism represents some process which is modifying the nature of one into another. So this metamorphism is nothing but a process of, can be done by dynamic, thermal, dynamothermal. Dynamic in the sense represents pressure, thermal is heat. This is both pressure and temperature or heat. So this morphism is taking place either by pressure or by heat or by both. So any of these three processes can change one type of rock into another, which means that chemical structure is changing into another. What is the example for this? Limestone is changing into marble because of this metamorphism process. So at the end of this, so types of rocks. So we have igneous rocks, sedimentary rock and metamorphic rocks. Why have learned this? So there are three different types of rocks produced different processes. So combinedly, all these types of rocks have different chemical nature. As for example, so we have an earth surface. Lithosphere is present from the surface. At shallow level, we will be getting asthenosphere. So asthenosphere, all the volcanic eruptions are triggered from asthenosphere. So this materials will be pumped through a volcanic tube to the surface. So lithosphere will be consisting of different minerals, whereas your asthenosphere will consist of different minerals. Say for example silica and alumina. So there are different natures. So as far as earth is concerned, silica is playing a major role. Silica is 60% about present in our earth. So alumina will be something around about 20%. It has variant. So this constituents, ingredients as changing with respect to, we have also some other types of minerals and elements. So this processes will produce such rocks which consist of different constituents. So that is what I am coming to say at the end of this petrology. So we have different types of rocks which consist of different constituents of minerals. So we have rocks. Then how the soil has produced. Exogenetic processes, endogenic process. So it is a process playing role by external agencies. Endogenic process represents internal agencies. What is external agencies and what is internal agencies? So these processes are nothing but can transform soil, can transform rock into soil. That is nothing but disintegration. So this disintegration is a process producing soil which can be either produced by external agencies or internal agencies. External agencies, we will look at into external agencies. Weathering. So weathering is an external agencies playing role, weathering, so transforming rocks into soil. So we have three types of weathering here. physical, chemical and biological weathering. Physical weathering, or in other name it is an mechanical weathering. So we should learn about this weathering processes, then only it leads to the behavior concepts. So physical weathering or mechanical weathering. In a physical weathering, first thing is an temperature. So first discuss about temperature. Say for example, there is a rock which is at in a equatorial region. So at noon time, say for example 12 o'clock, or at that mid noon time, so temperature will be very high. Say for example 33 degree plus up to 40 degree it can go. So because of this temperature, your rock will be expanded a little bit, but we cannot feel that rock is expanding. We cannot identify through naked eye. So the rock is expanding little bit. Then during the night time, when the temperature falls, it is shrinking. So this expansion and shrinking will be taking place when the temperature changes. So it loses the bonds of soil, rock grains. There are minerals at the which forms the rock at this top surface. So this expansion and shrinkage will loses the bonds of the grains. So and it will be as a layer, it will be getting peeled off. So that is nothing but an disintegration. So here temperature is playing a major influence. So particles are getting disintegrated as soil. So second one, once temperature is got over, we have freezing. How freezing is acting, which means during say for example at northern or southern poles, we have a temperature fall as minus below 0 degree. So when rain comes, at the surface of the rocks we have minute pores. When the rain comes, water get enter into those pores. As we know that when the temperature falls, this water molecules will be getting transformed into as ice. That process is nothing but freezing. So during this freezing processes, so volume expansion will take place. Volume expansion of water molecules will take place and forming ices that can break a bond of an rock at the surfaces. So that will disintegration is automatically taking places. So this is happen due to this ice freezing, as well as at seashore we can see. At the seashore, we have a salt water. So we are feeling salty at the skin when the wind is blowing towards us. So at the surface we can see that salt is deposited at the skin. So likewise it is also deposited in the surfaces of the rocks and just getting infiltrated into the pores of the rocks once the temperature rises. Whereas your freezing temperature falls, but in this case it is a little bit different. Temperature rises, so that salt getting crystallized. So here also expansion take place, both freezing and this crystallization, expansion taking place, which can lose the bond of the grains of the rocks at the surfaces, which will produce soil. I hope you have understand. For a best example I can give, we are using refrigerators. At the freezing zone, we are keeping water into a plastic container. If you keep that water into glass container, during the freezing time your glass will get broken. Thus represents volume expansion. If you place the water in the plastic bowl or any container, so it is in flexible nature and it won't break. So that is the reason we are keeping plastic containers into freezing zone. Freezing is over. Then collision. So what is collision and how it is playing major role to produce soil? So collision is nothing but a collision of rocks to rocks or something else. or it is rolling down from a mountain. So collision is playing major role by gravitational. So during any earthquake or something else, so a rock body will be rolled down from the higher altitude to lower altitude. So during this rolling, it is subjected to some collision of some other rocks present at the mountain surfaces, and it will be getting broken. Maybe it can be broken into very large two pieces. That is nothing but that is an influence of gravitation. So collision we can say. So during this particle collision, so the whole rock can be disintegrated, whole rock can be broken into two pieces, or some pieces will be produced as a rock from the surfaces. So that is collision, gravitational influence. Sudden unloading. So what is sudden unloading? Sudden unloading is nothing but a rock. Say consider there is a rock, over which there is a rock of huge mass. During the earthquake process, the rock present over an rock will be displaced. During this displacement, the rock which is lying below, which is under huge stress before that movement, but now it has moved and there is an distress. So this distress also can break the rock. So this is due to sudden unloading. Then attrition, abrasions are playing very major role. Now we can say there is an rock. So now there is a blowing wind. So this blowing wind may consist of some soil particles which have already produced. So the soil particles, heavier particles will stay down very nearby to the earth surface, which cannot be lifted higher because it has comparatively little bit heavier than this small particles. So small particles are staying just little bit above the heavier particles. So this smaller heavier particles will be rolling at the surface, known as saltation, and these particles are suspension. So this saltation and suspension will be abrading the surfaces during the collision. So this is nothing but attrition, and abrasion is nothing but the wind alone can abrade the surfaces of rock. So that is nothing but abrasion. So this huge rock will be coming to this like this when this wind action is taking place continuously. So that is all about some processes. So that is clarifying that physical weathering. So at the end, so all these processes, different processes producing rock, producing soil, rock into soil.